We are dealing with part one of understanding numbers, which is the fundamental basics of pre-algebra. So we would want to start with understanding numbers, and I have created a structured taxonomy of numbers, which is the classification of numbers based on their shared characteristics. So we have two main categories of numbers, and the main are real numbers and imaginary numbers. And when we talk about real numbers, we are talking about rational numbers and irrational numbers. We are also talking about fractions, integers, whole numbers, and natural numbers. So let's just go and look one by one. This group is not a common group, imaginary numbers. We don't talk much about these complex numbers or imaginary numbers. These are just numbers that are a bit unusual, is the ones we have been dealing with. If we are to press on the calculator to find imaginary numbers, we would realize that our calculators will say error, or they will be giving us an undefined notification. And this simply means that the operation is not really making sense. For example, imagine real numbers comprises of taking a square root of a negative numbers. The square root of negative numbers, I remember at some point, or if you didn't yet look at it, you're going to see that it's almost impossible to take a square root of a negative number because you can't square a number and get a negative number. So you can't have a square root of such a number as well. So which means if we are to really start a little bit deep, we're going to see that we call, in general, actually, we call the square root of -1, we call it imaginary, which is represented by the lowercase I. So therefore, actually, that's what I pre-record or pre-wrote here. You want to see that the square root of -1 is I. And then, so the square root of -4 will be -2, because square root of -4 means square root of 4 times square root of -1. So square root of 4 is 2, and square root of -1 is I. So that's why we end up with 2I there. And now the other division that we can deal with is of the real numbers. Real numbers, these are numbers that include both irrational numbers and rational numbers. When we talk about irrational numbers, these are numbers. It's a set of numbers. It's a set of numbers. Irrational numbers, set of numbers that cannot be expressed as fractions. That cannot be written as fractions. Or in other words, we are saying irrational numbers, they have what we call they are decimals. They are non-terminating decimals. Non-terminating and non-repeating. They are non-terminating and non-repeating decimals. For example, of a non-terminating or non-repeating values, let's talk about the square root of 2. Let's talk about the square root of 2. The square root of 2, if you look careful, is equivalent to 1.5 4, 1, 4, 2, 1, 3, 5, 6, 2, 3, 7, 3, continuously up to infinity. We can't end this number, it doesn't terminate. And if you look at this value, it's what we call an irrational number. We can also talk about another special number here, which is the ratio between the circumference and the diameter, which is the pi value. If you look at pi value, you're going to realize that pi value is also a non-terminating or a non-repeating decimal, because the commonly we know value of it is 3.14 159 265 35, going on and on. Doesn't terminate as well. So this value, it cannot be expressed as a fraction where the denominator is an integer and the numerator is an integer, like what happened when you deal with what we call the rational numbers. If you look at rational numbers, they are extremely opposite, that this is a set of values. These are a set of values that can be written as a ratio of two integers. For example, we talk of 1 over 2. We can talk of -3 over 4. We can talk of 5. This is also a whole number. That's a rational number because we can say 5 over 1, etc. We should also mention something here on this. We should only, when we are dealing with rational numbers, the only value that cannot be the denominator is 0. So we can say we can't have a value that is having 0 as the denominator. We can't have such kind of a fraction. We can't have it. And we will talk about, in these rational numbers, we can also talk about that there are some values that are also non-terminating, the same as the rational value. But the only difference is when we talk about our rational numbers, they are there are some values, yes, that are non-terminating, but they are repeating decimals. The difference is on irrational numbers, they are non-terminating and non-repeating decimals. But when it comes to rational numbers, they are non-terminating, but they are repeating decimals. For example, we can talk about 1 over 3. 1 over 3 is equivalent to 0. That's 0.333333 up to infinity. You can see that it's not terminating, but there is a pattern that we follow, that after the 0.3, 3 continuously to repeat itself. So it's having a repeating decimal. We can have as well 1 over 11. We can have 1 over 9. We can have 2 over 9. We can have 1 over 7. Yeah, that's a unique one. 1 over 7. If you look at 1 over 7, you will realize that 1 over 7, it can continuously go as 0.14 285 7. But after this value, you are going to realize it's going to start over again, 142,857, then 142,857, then it goes again. This is, you can see as well, it's a repeating value. This value, it's repeating itself again. So this is also a rational value, but it's also non-terminating, but is having a repeating characteristic. So it can go forever and forever, but with a certain pattern. And we can also categorize rational number. Rational numbers, they can be either fractions or integers. Fractions, we talk much about fractions. I gave you on top, that's a typical example of fractions. By definition, fractions are these are numbers which are between integers. These are values. Let's say these are values between integers. These are values between integers. So, for example, let's talk about between 0 and 1. What values do we have between 0 and 1? We can talk of half. Yes, it's also a value between 0 and 1. We can talk of 3 over 4. We can talk of any value that we can find in between there. We can also have 2. So the values that are also between 1 and 2, we can talk of 1.5. It's a value, it's a fraction as well. Although this kind of a fraction is called a mixed number. A mixed number, it consists of a whole number and a fraction. That's why we call it a mixed value. So we're going to talk more about these numbers a little bit later. Right now, let's just do the classification. And another division or another branch under rational numbers, if we don't have fractions, we can have the opposite of fraction, which is an integer. Integers, these are whole numbers. These include the negative and the positive values. If we talk about the integer, we are talking about the negative and positive values, right? And most probably we're talking of most whole numbers that can be found on their number line. So here we have whole numbers, and when we really talk about whole numbers, we are talking of these are all positive values from 0 altogether, e.g. we are 0, 1, 2, 3, 4, going up to infinity. And we also have a special kind of numbers, again, the natural numbers. When we have the natural numbers, we are talking about positive values that are starting from 1 going to other numbers. We are talking of the positive values, natural numbers. These are positive values starting from 1. Starting from 1 altogether. So we are just saying they don't include 0. So it includes all whole numbers except 1, except 0. I mean, these are positive numbers from 1. So we are saying are all whole numbers, except 0, which means 1, 2, 3, 4, 5, go to the positive side up to infinity. This is the taxonomy of numbers. This is the